Good
Today, we
evening,
are
ma'am.
here to celebrate National Mathematics Day in the honor of Shri Srinivasa Ramanujan sir. We are thrilled to have with us Mr. Mithun Kumar S R as our chief guest for today. So let's start today's interactive session where aspiring change makers learn from the real life change makers. Firstly, I would like to invite Sir Mithun Kumar to introduce himself.
Hey everyone, it's good to meet you all. I'm Mithun and I'm an engineering manager at Google. Uh, I've worked with other companies as well. I can brief you about all of them in a while when I go over my slides. But it's very nice to meet you all on this special occasion. Thank you so much for inviting me.
Good evening, sir, and welcome.
Thank you. Thanks, Monica.
Very well. Thank you, sir. And let's talk about STEAM Varsity. STEAM Varsity is where we get science, technology, engineering, and arts and mathematics education based on innovative programs and hands-on experiences to empower students for the challenges of the future. So, let's start this meeting by lamp lighting.
लैपटॉप का चला गया
So, let's start our interactive session with Sir.
Awesome. Thank you so much. So let me share my screen and we can get started on this. All right. Cool. I'm Mithun, and it's really great to meet you all on this special day because mathematics has transitioned and transformed in various of these. I just wanted to ask you all, how many of you really like maths at this point of time? A quick show of hands, or maybe use your smiley. Okay, that's nice. Let me ask the other way around. How many of you are hating maths at this point of time? Let's be honest, I was one of them. So, how many of you are still hating? Yeah, and what are the reasons we are hating maths at this point of time? Any of you? Please feel free to unmute. I just wanted to make it as interactive as possible. What are your
Y-
reasons?
y- yes, sir.
Yes, yes, please go ahead.
I am hate the maths.
It's hard to understand. Is that the reason?
Yes,
Okay, valid point. Even I was facing the same issue. What are the other reasons?
because of his hard formulas.
Formulas, a lot of formulas, right? We have to remember multiple of these formulas. Interesting. What else comes to your mind? What are the other reasons why people are hating maths? I mean, my reason was my understanding of each of the formula was taking a lot of time.
Learning formulas.
Lot of learning formula. I am with you. Okay. What else?
Because
Because we
solution.
do the same thing again and again,
Same thing again and again. Very good. Okay.
mostly.
Yeah, yeah, yeah. I'm with you as well. Okay. What else?
Solutions getting longer and longer.
It's getting longer and longer, right? I know every year there are new things which are getting added to the syllabus.
A
Okay.
small mistake get
Yes. What's that, Kushi?
what's the
You said something. I missed you.
yes, sir. I said a small mistake get hold
Amplified.
up.
True, true, true. A small mistake you make and then it gets amplified everywhere, right? And we lose the answer. for whatever we are doing. Very good, Kushi.
The frustration of not knowing where the formula really comes from, I feel, is one thing I don't really like in maths.
Oh, I mean, that's something that I was doing wrong as well. I didn't know how to learn math, and we were probably memorizing a lot of things, even without understanding, hey, where am I going to use this? A good number of people that I talk to say that I have learned probability, I learned statistics, I learned calculus, but where am I going to even apply this, right? And probably all of this is what will give you some insights on where to get started. And perhaps speaking on this day where uh, we are celebrating maths, and India leads the way for the entire globe as well, and you all as uh, mm, budding mathematician, technologists who are going to lead the way next, it's important that you start to understand this. That's why I am here. Okay. So, some quotes from Srinivas Ramanujan: there's no shortcut to success in maths. It definitely requires long, hard, and intense effort. But on the other hand, understanding the concept where it's going to be used, the applied part of math will make it a lot interesting. And that is where I'm here to tell you about something on the machine learning. How many of you are using machine learning in one or the other form? Yes. Okay, Anand, where do you use it? Where do you use machine learning? You're muted. Feel free to unmute yourself. Okay, others, if you want to, someone wants to unmute and tell where do you use machine learning?
The most basic one I feel is using ChatGPT and all such AI platforms.
And also we use robotics, like machine learning in robotics also, like doing different kind of things, recognizing objects, this
Good,
also.
good. Super, Sumit. Very nice. You brought in all key aspects of machine learning. Who else knows about machine learning? Where else are we using it?
We can use it for various tasks, including natural language processing, computer vision, and also we can use it for data analysis and
Wonderful,
various other real life applications.
wonderful, wonderful. So machine learning has actually entered our lives without we even realizing it. For example, okay, I missed it, Pragya, but I was just telling that it has entered our lives so much that it's hard to imagine a life without machine learning, right? For example, you go to YouTube, you open YouTube, automatically you get recommendations. Facebook, you get automated recommendations, right? All of these have some or the other artificial intelligence that goes behind the scenes. And now it has entered our lives so much that we rely on it to make our lives even better. This is where we want to see that what is that unforeseen uh, force that we have, and that's exactly the topic that I want to speak to you all about. Where is mathematics coming in AI and ML? How is it actually going to impact us? So, having understood this, you can focus a lot better. You know that where exactly am I going to use the concepts, and then you can now start to think like a AI scientist. Are you all ready? Shall we go ahead with what we are planned to do?
Yes, sir.
Okay.
Yes, sir.
This is a brief about me. I'm an ML engineering manager. I have about 18 years of industry experience. I previously worked with Uber, Amazon, Flipkart, Siemens on various roles, and my PhD is in natural language processing. My research interests are around graph neural network, how to understand AI. Now, this is also gaining importance, AI explainability. This is where I primarily work on the research side. I also teach in many universities. So, this is a brief about me. Okay. Having said this, AI is becoming more than magic. For example, I heard Sumit saying that robotics is gaining importance, right? For example, this is one of them which is used in Parker. It could do multiple of these things. when you notice, right? Now it's able to navigate, it's able to understand, it's able to look through all of the obstructions, objects, and then it's also able to perform like multiple of these tasks without any inhibition. So AI is becoming magical, but the fundamentals of everything that it's built on is on mathematics. And what we'll do today is we'll explore what are the key mathematical foundations of AI. We'll try to also build an intuition around how to make ourselves better in math. Okay, this is primarily what we are going to look for today. So now that we know that there is something that machine learning depends on, which is on math, my role here is to help you understand, hey, what are some of the key algorithms that we are going to think of. For those who are new to it, don't worry, feel free to ask me questions at any point of time. And I just want to keep it at as simple as possible. So, in case something is overwhelming you, feel free to ask me about any of them, right? We'll also look about how do I build models. Any of you built ML models here? Have you used one or the other ways of building ML models? Any of you?
Yeah, I have done it. Like
Okay. And
for
what have you with? Uh, what models have you built here?
like I have built a model to like recognizing the blocks. Like there is a challenge FTC, so I have built for that.
Wonderful, wonderful.
Yeah.
Haris, you also raised hand. What models have you built?
Actually, I've built models on computer vision.
Computer.
Basically, computer vision.
Wonderful.
In my college, for a major project, we made what do we call it? American Sign Language Recognition Model.
Wonderful. Sign
So
language
that's
is a hard problem as well. And you went about, so you're gesturing and the model is able to detect what is the
it was able to detect the letters, not the words.
good.
So
Good. Important problem. I solved it for a good number of years. So hard problem, I understand. Adya, what have you built?
So it wasn't particularly me, but day before we took part in a hackathon and we were supposed to calculate the runtime. We were supposed to reduce the rundown time for a specific part of an aircraft. So we took a fuel tank cap and we took data like pressure, temperature, and creep rate, and then we trained the model to calculate how many cycles it would take before it was supposed to be replaced.
Wonderful. You have done a lot of optimization around this. Good, Adya. Good to see this.
Thank you.
What others have people used? Okay, we'll over a period of time we'll see how we have been using in one or the other form. So the more we represent it mathematically, it makes it easier for us to clarify on how complex models are being built, right? So when I look at it, these are the key areas of focus what we have, right? Anand, did you have a question for me?
Sorry, your voice was breaking.
Okay,
My dad's name is on the computer, so my name is Neil.
Neil. Okay, okay,
So
right.
can you repeat what you said because your voice was breaking?
Okay, so I was just saying that these are the key areas of focus in math, what we would want to focus on. Okay, so how many of you are in high school at this point of time? If you could raise your hands, I just wanted to know if you have all heard about this in one or the other form. Okay, Hansika, who else is in high school? Okay, how many of you are in inter or in college? All others are in college then? Okay. Other folks from primary school as well? Primary or middle school? Okay. There are good number of people. Then I'll ask you the other way around. How many of you don't recognize any of these words which are shown on the screen? Any of you who are not able to recognize these words? It's perfectly okay. You might be still learning this. Perfectly okay. Okay. Neil, Saloni, uh, Ratan, and a few more. Okay, okay, sounds good. I would just keep it very simple so that over a period of time, when you are learning it, you know something is coming up in this area, and you can start to practice that. Okay, all right. So these are the five major disciplines that I'll begin with. right? One is linear algebra, second is calculus. Probably during your high school, you might get started with this. Linear algebra, you might get started in your grade 5, 6, 7. All of this that you are starting to build will show up in one or the other form. Probability and statistics, somewhere around grade 8, or is it even taught sooner? I forgot. I don't remember when I learned it. When is this taught, probability and statistics? Somewhere around grade 8, grade 9, or even
Yes.
Grade 9.
grade 9. Okay, okay. And then we'll look at optimization and some discrete mathematics as well. If the terms are overwhelming, just make a note, don't worry about it, right? Now, whenever we speak about data, there's a lot of data around us. Now, that is what makes it interesting. All of these, like machine learning, artificial intelligence, came into being just because we are now producing a lot of data, which is always produced, but we are able to save it and we are able to make a good sense of it, right? And how do we do that? This is the way we are representing the data. All of you would have probably seen like a vector or a matrix, right? So we have a scalar quantity. For example, when you just give, still the same, Neil? Are you not able to hear me? Is it the same with everyone or just Neil? Okay,
No,
No,
sir, I
I
can.
understand what you said, like about what
Not
you're saying. I
clear.
haven't seen it.
you haven't seen it. Don't worry. Huh? I'll make it simple. So you have data. For instance, the data could come with a simple thing like this. For example, it could say Neil. Where does Neil reside? Neil resides in. Where do you reside, Neil? Delhi?
New colony.
New colony. Okay. We say new colony. And then this is a data for us, right? It has a person, it has a place. Now we have to start representing it in mathematical form, right? How do we do it? We just bound it in an array, right? And we say that here are here are the variables. One is a name that we are giving, another is the place where the person is from, right? So once we have this, we have some way of representing it mathematically. We can say Neil is equal to 0. Whenever I call 0, it represents Neil. Whenever I represent 1, it means new colony. So now I can play just with numbers rather than these words, right? That is what I'm putting it in vectors and matrices form. Now, where is this used? Because we deal with a lot of data, dealing with strings or these words which are in English or Hindi or Telugu or Marathi, any of these natural language is harder. But once you convert everything to math, it becomes a lot easier, right? This is where we start to represent the number, the data in this form. So whenever you come across this matrix or vector or scalar, these are the kind of things that you would see, or it could be tensor. You'd notice TensorFlow units or a TensorFlow kind of keywords coming up in ML, right? So there are a good number of libraries which are called TensorFlow. It all derives from this. So you have vectors, matrices, and so on. So when you are studying, now you can start to represent a lot of data. So you could represent a 1D data, something like this. You have matrices with multiple of the variables. For example, whatever we were showing as name and where the person is from can be represented easily as a vector here. And once you have vector, you can do a lot of manipulation on top of it. So representing it in a vector form requires for us to understand what matrix is. This is where we start to leverage it. When you look at the application, any of the ML model, for instance, you have a huge amount of textual data, or it could be MRI image or X-ray image, right? You would want to represent each of this into something that the computers can understand. And what do computers understand? Just numbers. It doesn't understand what you and I are talking in this natural language. right? It can just understand numbers. So we convert all of this into a numerical form, like 12, 213, 44, 15, and so on. And there's some amount of AI which is going on, AI magic. And then the output is also going to be a number. And we are going to interpret this, and we are going to figure out if this is something that we have to work on. Any questions so far? So we understood one single concept, that is, there is vectors, matrices, any kind of data will be represented in this form, and the output is also going to be in this form, irrespective of whatever ML model is. So whenever you start learning now linear algebra, now you can figure out that, hey, probably there is data representation that I would need to use this for. Any questions so far? Please ask me. Uh, if it is also overwhelming, let me know on that as well. Is it okay with all of you?
It's
Yes,
okay,
no.
sir.
Yeah, yeah. Thanks, Adya. Noel, did you have a question?
Yes, sir. Could you tell what this tensor, what does it mean?
Yes. So what you see here is basically a m cross n matrix. It has number of rows, right? How many rows are there? One and two. How many columns are there? Three columns.
Right,
So m cross n is 2 cross 3. This is a matrix.
right,
Whenever it is of only single column, it is called a vector, right? Which is the number of rows could be as many. Here in this case, it's three, but the number of column is just one.
one.
It's a column vector. It could also be a row vector, which means one row and multiple columns to it.
Right,
But whenever there are multiple columns, multiple rows, this is known as a tensor. So this is a higher order. It's like a Rubik's cube, right? Whenever you're adding more, it becomes like multiple rows, multiple columns. Each of them is representing a data. Now, why is this required? Because our data is getting complex. We have to represent like in multi dimensions. You can't just represent in two dimensions, three dimensions. Whenever you need more dimensions, that is where tensor comes into play.
okay,
Make
got it.
sense now? Okay. Any other questions? Okay. Let's keep moving on. Now, once you have this, you can start to apply a lot of linear algebra as well here. Neil, did you have a question?
Yes, so I was asking like that, like you said in bigger dimensions we will use tens.
Correct.
So on, so I'm wondering that if there's one, like if they're the same, the same rows on each column, will there be used tens in it?
That's a very good question. If it contains same rows, do we need tensors in it? Probably not, right? Here, because each of these are unique values, we are putting it in tensor. If it contains same values, probably matrix is good enough or a vector is good enough. We might want to figure out based on the data, based on the complexity, we might want to change it. Okay. All right, let's keep moving on. Now, when you look at it, there are a lot of things that you probably are learning now. What are the things that you're learning? You see that there is some multiplication which is going on, right? There is some addition which is going on. There are some functions which we are using. And then there is also multiplication here, and there is multiplication here. So whatever we are learning will be applied in one or the other form. Now this is an example of what we call it as neural network. What is the neural network? It represents how our brain is also working. Our brain has a lot of neurons where it does a similar amount of calculation. So what we are trying to do here is we are trying to mimic it, and we are trying to figure out if we can start to leverage something similar to our brain structure. Now, this is where another application of where we see linear algebra, wherever there are number of points that we would need to do multiplication, we need to do addition, and so on. We still go ahead with using the underlying foundation is just plain simple linear algebra to it. Okay, any questions? Is it interesting so far? Are you able to follow whatever I am telling? Okay.
Yes, sir.
Good. Let's keep going on. Now, when you look at it, I said most of the ML models work similar to what our brain does, right? So, brain has this neuron structure where it is it is connected to each and every cell. So, for example, I'm able to lift my hand. This is because the brain is signaling my hand saying that lift it, right? And then I'm able to coordinate accordingly. I'm able to see you all. I'm able to talk. All of this is because of what the brain signals are. Now, similarly, in using the same context, what ML did is they took up multiple of these features. Assume this to be a signal which is coming from eyes. Assume this to be a signal which is coming from nose. You're smelling it. Assume this to be coming from skin, and so on. So these are all called features. So various features are going in, and then we are doing multiple of these linear algebraic terms to end up in some output. This is what the
Sir,
fundamental of math is. Yes, yes, please
sir,
go ahead. Yes, I
I
am.
I hate the maths because of because confusing of formulas and multiplications and divisions, etc.
Yes, I am with you. There are a lot of things for a small brain like you to take in, right? So how do you get better at that? One is don't memorize any of the formulas, right? Memorizing will make it even more harder. Rather, understand what you're trying to do. So, for instance, if you're starting to learn about addition or subtraction or ratios, proportions, these are some of the things that you're getting started, right? So please try to understand how things are being used. For example, if someone is asking about ratio, I'm slightly deviating from ML, but I hope it's okay. For example, try to see how you could apply ratios and proportions. You're taking a pizza, you're cutting it into four, and if you want to give it to a friend, you are giving one portion of this. So, how do I represent this mathematically, this one portion of this pizza? So there are four portions, right? And I want to give one portion to a friend. Now this becomes a lot easier for us to remember rather than doing rote memorization. So try to learn things by visualizing. The more you visualize, the better it becomes for you to go and apply. Jyoti, did you have a question? Okay, Ayan, did I answer you at least some intuition of how to learn math? So try to apply, try to make, try not to memorize things, but try to understand how things are being used. It'll help you whenever you're trying to learn it. You visualize using a lot of geometry. For example, you're learning this a square plus b square is equal to what, right? And then it's easier if you are starting to put what the value of a is, what the value of b is, and then you know this is square root of a square plus b square. Now these things become a lot more intuitive if you're trying to visualize it in some geometric form. So don't like never go with memorization, but rather go about in seeing it as a picture as much as possible. Okay, Anand.
That I actually do have a book on how to
Yeah,
be good at math, so that's what I'm doing. I'm like not memorizing it. I'm still on the first page. I just keep reading it until I get to know like what it means, because I still don't understand, because there's like writing in some other languages and many other languages, so the numbers are in Roman, so I'm still
numbers
able
in
to
Roman.
understand.
Yeah, that's another problem that math gives us. Everything is in Roman. The script you would need to understand. There are
Like I
some.
understood half of it, like most of it. Now I'm understanding the 100 and 1000.
Very good, Anand. Very good, Neil. Sorry, I'm seeing the screen name. It's your father, and you're Neil, right? Okay. When I was your age, probably I would never read what M is, what L is. I still struggle with all of these Roman numerals, and I'm really glad that you're putting an attempt in each one of them. So it's the good way for you to begin with. And I understand it's going to be taking some time, but once you understand the language, it makes it a lot easier for you to speak with everyone, right? So that is how you get better day by day. And I am also going to slightly deviate. Another way that you can start to understand is by doing things. So, all of you use some kind of uh, LLM, as we call large language model. It could be ChatGPT, it could be Gemini, it could be Llama, or multiple of these. For instance, even WhatsApp has this, right? Ask WhatsApp something, ask AI. Now, for
It's
you to
called
begin,
Meta AI.
Meta AI, very good. I missed the name. So, all of these are some good ways in which you can begin understanding. For instance, if I were to begin now, how do I start? I will ask, teach me how to learn linear algebra, or teach me where is it being used. These are the prompts that you can give to any of this. So let's open probably chat gpt. I want to see show you certain things that what I generally do, which makes it easier for us to look at it. Let me pull it to the screen. Okay. So now I'll ask uh, GPT on certain things, right, which makes it easier. For example, teach me about vector addition and show me where is it used, right? Once you do with such natural questions, it starts to give you some answers out of it, right? Now, please leverage these technology. It didn't exist when I was studying, but at this point of time, these are the resources which are easily available to you. And there are good number of YouTube tutorials as well. There are good number of resources like Khan Academy and so on. These are the things that you should do, and STEAM Varsity also does a wonderful role in this. So please leverage all of these resources which are given to you to understand each and every concept, right? And another one that you might want to figure out is, for instance, you'd want to ask it, teach me like I am in grade 5, right? Even if you're in higher grade or lower grade, you can ask it to break it down according to whatever your usage is. Now, these resources are freely available to you. Haven't brought any subscription, but these kind of resources will make it a lot easier for you to work on, right? This is my first tip in terms of making math learning easier for you. Now, the more you start to do this, it becomes easier as you go about in breaking it, right? Similarly, you can use other LLMs as well. For instance, this is Gemini. I can do a similar kind of prompt. For example, teach me about tensors as if I am a 10-year-old, right? So it'll now break it to me and showcase what it is all about. It makes it a lot easier, intuitive. Then you can ask it, give me some assignments to try, right? So the more you keep doing such things, the better you will become in also not doing rote memorization. All good? Okay, let's go back into what we were talking about. Now, similarly, the next one that we are speaking about is ANN. Any of you know what the full form of ANN is? What is
Artificial
ANN?
neural networks.
Artificial neural network, right? So there are neural network that we are human brain has. Similar kind of neural network, we would want to build it artificially. This is where we would want to go with building artificial neural network. You see a lot of formula. These are all very intuitive. You take the weights, you multiply it with the data, plus you add some bias, and then you get it. So over a period of time, you will start to also understand and appreciate how things are being used. Then you might come across various of these terminologies. What I'll do is next 5-10 minutes, I'll quickly cover some of the concepts. For example, eigen. I don't know how many of you have heard this term eigenvalue, eigenvector. Adya, you have. Okay. Others are yet to see this, right? So I mean, when I was reading this, we have matrix, and then we have eigenvalues and vectors. We try to figure out, hey, where am I even going to use this? Is there even some application of this? But at some or the other point of time, we realize this is where we start to leverage this in one or the other form. Is my screen still visible? I see others too.
It's not visible.
Not, sir.
Visible, right? Okay, I'll pin this. Maybe
There
someone.
is like another one who is sharing the screen, Sudha Kumari. Like she is sharing the screen right now.
Okay, cool. I think we are back, right?
Yeah.
Okay. So when we look at this eigenvalues and vectors, so there is something known as a matrix which is non-invertible, which has zero and things around it. Now, I'll skip all of the complexities to make it a lot easier. I'll also share this slide deck. You can go through a lot of videos towards the end. But now, where is it being used? Whenever we are looking at data, it comes in multiple dimensions. For example, I told Neil is from New Colony, and then how many dimensions are there? This is first dimension of data. This is second dimension of data, right? There are two dimensions, but there could be more as well. For example, I can say Anant is father of Neil, and I can also add Neil is in which grade? I
Sir, your screen is not visible.
not visible.
Yeah.
No, sir, it is.
Yeah, to me also it isn't visible.
Right.
Same here.
Okay, let me reshare it. We'll see if that fixes this. Now, is it visible?
It's visible right
Yeah.
now.
Yeah.
Okay.
yes.
Okay, so I was telling there is a name, there is a place, there is father's name, there is class, and so on. Each of them represent one dimensions to us, right? So there are four dimensions. What happens if I'm overwhelming with a lot of dimensions? What will happen to the system? What do you think will happen to the system which is learning from multiple of these dimensions?
Overloading, like,
Overloading, right? When you're also given a lot of subjects to learn, at some point you will break down. Very similarly, the ML models also, when you're giving too many things which are not necessary, it will also not learn anything. So we go for something known as dimensionality reduction. And whatever we are speaking, for example, we want to reduce data from two dimensions to one dimension or three dimension to two dimensions. These become easier when you're applying eigenvalues and vector, where you're looking at what is that dimension which will add more value, and I'll keep only those values and I'll keep rejecting all of the things. This is where we start to apply eigenvalues and vectors. Any questions so far? Am I making sense? Okay, let's keep doing a little more. We have principal component analysis. Now, for example, I'm trying to find, hey, what is the uh, rate of house in a particular locality? For example, I might be looking at locality A, locality B, and C, and D, and so on. So I might have a lot of data related to it. For example, I might look at number of bedrooms in it, right? I might also look at what is the color of the house, and I might also look at what is the dimension of the house. So there are good amount of data which is shown to us. Now, uh, is the color of the house going to increase or decrease the price of the house? Do you think so? Perhaps not, right? Probably the number of bedrooms, the dimensions of the house will add more value, and it will increase the rate of the house than the color, because color can be modified by anyone. Did you have anything for us here?
So can we call it feature selection?
Feature selection. Very good. So each of these represents features or dimensions, right? Now, what we are trying to do is in this principal component analysis, we try to find the pattern. We try to do dimensionality reduction. For example, color is not required. I might want to eliminate it. I might only want to keep the number of bedrooms and the number of dimensions only. So these are the things that we start to do by using the linear algebraic formulas, right? So we can go about in reducing the data, we can keep only those which are required. It makes it a lot easier. Similarly, we have scalars, vectors, matrices, and tensors. So depending on how many of the dimensions are required, we can start to leverage them to make it easier for us to multiply. Whenever we want to multiply word with word, it becomes harder, right? So this is where we go about in dimensionality reduction. Similarly, for face recognition, we use eigenfaces. So for most of the face recognition, where do you use facial recognition systems? Any of the applications
Like
you use?
where we have to do something like attendance system or like um, yeah.
Security system and so on. Okay. Where else have you
Security
used facial
system
Bank,
or attendance systems.
attendance systems? Very good. And what is
surface unlock in mobiles.
very good. That is what I was asking. Like, where do you use in the common area? You just open your phone with face unlock, right? You use your face to unlock. And what is going behind the scene is also eigenfaces. What is happening? It's able to recognize the facial features. There are a lot of facial features on us. It recognizes that, it identifies the principal components of facial features, and it also unlocks it. Because, did you have a question? Okay, let's keep moving on. Feel free to ask me questions at any point of time, right? Now, similarly, we have deep learning. People speak about deep learning with weights, biases, and so on. It also uses some kind of matrix. We do matrix multiplication between A to B. So this is represented as a matrix value. This is represented as a matrix value. Whenever we want to combine these two, we go with the product, dot product of these two. This is also something that we go with matrix multiplication. Now you could start to see that, hey, it's not everything, whatever I'm studying is not going waste. I'm using it in one or the other form, right? So I could start to look at weights, I could look at biases. Whenever I want to convert an image into a vector form, right? Whenever an image is given, now what is shown on the screen is probably the number 9, right? But when I want to break it, what do? I go about in using something known as picture element. This is it is like an atom, right? Atom is the most fundamental form for any molecule. Similarly, for any kind of computer vision, we go with picture element. In short, we call it as pixel. So we use pixel in one other form, right? For example, to showcase, hey, what is this photograph about? Or whenever you are saying this TV is of uh, 4K quality and so on, it basically represents how many pixels are there, what is the resolution it can bring in. Now, when you want to break it, how do you break an image? You break it into, for instance, here I have broken it into 28 rows and 28 columns, right? And it is giving us 784 different numericals, which I'm saying these all contain black, this contain grays, this contains gray, and this contains white in a particular pixel. Now I can start to represent each of this by 000, and whenever it comes to this part, I can say 1, right? Rest everything will become 0, and wherever I have some value to it, it becomes 1. Now once I make this kind of image manipulation, it makes it a lot easier for me to work only with numbers by doing basic addition multiplication. I could use it in computer vision as well. This is another form where I want to use in one or the other form. Do you have any questions so far? Okay. Now I could also start to reduce the dimensions. For instance, here it's all pixelated. I want this to be smoothened, right? For smoothening as well, I would be using vectors in high dimension. I would try to convert in one or the other form. We'll use convolution, we'll use like multiplication and so on to make it easier for us. For now, if you don't understand certain words, it's perfectly okay. Uh, just use it as a motivation. where all are we applying this, right? And then you'll start to gain mastery over a period of time. So when we have huge amount of data, it makes it easier for us to represent it in matrix form, and matrix multiplication is easier, matrix addition is easier. So whatever you are doing as part of that will make it easier for you to work on it. Okay, cool. Having said this, each of this row will start to show up, each of these pixels will start to show up in each of the row, and will start to represent it in the matrix format. Did someone have a question? Okay, let's keep going on. So once we have this, it's easier for us to do this simple number manipulation. I Yeah, I could also go with sparse ML. Sparse ML is you don't have a lot of data. Still, I want to go with it, right? For example, I want to go with understanding MRI patterns. I want to understand X-rays. I want to know that, hey, what is wrong with a particular patient image and so on. So for doing this, you'll also do sparse modeling, which also introduces vectors in one or the other form. So I could go about and doing a lot more applications around this. Now, linear algebra is good. Second main topic is calculus. We have trouble in using calculus at one or the other form, right? We keep looking at, hey, we are speaking about differentiation, we are speaking about integration. Where am I even going to use it? Now, the simplest thing that you could look at is uh, you take an image, and whenever you want to detect that there is an object like this, right? And you would want to recognize this particular object. Let's say this is a MRI scan or X-ray, which is given to you. You would want to identify that there is a bone in it. What do? You try to cut an axis along this line, and then you try to figure out if there is a change in the intensity between this pixel and this pixel. We all know that we are talking about pixels, right? So there are multiple pixels onto it. So whenever you would want to find the difference between one pixel to another pixel, what do? Here is where you get the derivative. So whenever you are doing differentiation of a particular function, you know that you're subtracting one over the other. It makes it easier for your edge detection, for identifying objects, and so on. This is where you start to use derivatives. And similarly, for gradient points, whenever you want to go about and looking at have I reached the bottom, this is where you would want to also use differentiation. You keep taking derivatives at each and every point until it becomes minimal, right? You call it as minima. You'd want to make sure that you're reaching the minima during your optimization. Okay, Noel.
Sir, could you repeat that part? I don't think I understand properly.
Okay. So when you have a lot of functions around, I don't know if I have the slide. Okay. Now let's assume that you are trying to optimize a particular function, because machine learning algorithms, what it does, it takes in data, it gives the output, right? But in the first run, it will not be right. You'll probably need to show it with multiple of the data in multiple patterns. You show data 1, data 2, data 3, and so on. And over a period of time, it tries to optimize. Now, this optimization, you try to find it with some loss function. Hey, what is the loss at this point of time? The overall uh, objective that you would want to achieve is, at any point, the loss from any particular model needs to be as minimal as possible. Now, how do you go about in identifying whether a function has reached minima? This is by using differentiation. What do you differentiate? You do delta y by delta x, right? At any point of time, you take a tangent, you find the slope of it, and you try to figure out between this point and this point, is there something which is going down, which is called gradient descent. So am I seeing a reduction in whatever is happening? Now, because these are not linear lines. If it is linear line, you can take the difference between this and this point. These are all non-linear lines, something like this, which is having some curve. So you'd want to draw a tangent, you'd want to draw a tangent and keep differentiating across each and every point. So one of the applications of using derivatives is to reach the minima at any point of time, to detect change in intensity whenever it comes to computer vision. It is also used in natural language processing and one other. Does it make sense, Noel? Happy to go deeper, but I thought it'll make it a lot more
No,
complex. I
it's
know.
completely fine.
Yeah.
So it's basically like,
Finding the minimum. Whenever there is something which is given to you, you'd want to reach the base of it. And to reach the base, you go with differentiating it. You differentiate between one point to another point. You try to see if it's going down or up. That's
okay,
a very simplistic way of putting it, right? That's where differentiation and calculus comes into play. Okay, and we also go about in back propagation and so on. This is also another way that you would want to compute the error between one stage to another stage. You do a back propagation, you have partial derivative, or you have the second order derivative, and so on. It goes about in also computing the error at various stages. The third important topic, I'm going a little faster, but stop me at any point. I just realized it's already 7:54. So if you have any questions, feel free to stop me. Third is probability distribution, right? Because data is all random. We feel it's random, but there is always some or the other kind of distribution that goes behind it, right? So it could be a uniform distribution, it could be an exponential distribution, a normal distribution. A good way for us to visualize each one of it is, for example, in the classroom, there will be only few people who get above 95, right? There'll be certain set of people who are getting less than 30, and there are vast majority of people who are going to score 60% or so, right? Now this is where whenever you're plotting it, it makes it easier for us to visualize the data. So machine learning relies a lot on how do you visualize, how do you also interpret the data. This is where statistics and probability come into being. It understands the data, and then once you know it is falling under one or the other distribution, you can start to use it for hypothesis testing, for understanding the models, and then you can start to apply various of these formulas. Okay, all right. Now, some of you were speaking about NLP as well, natural language processing. Whatever you and I are conversing is natural language, right? You'd want to convert it into a number so that it makes it easier for computers to process. For example, I can take a matrix. I can say the is going to be 1 0 0 0 0. Cat is going to be 0 1. So everything I'm encoding it with some number. This is called encoding, right? I go about an encoding it, and then it makes it easier for computers and the ML models to easily give me the output whatever I'm desired. It makes it a lot easier for us to represent it in mathematical form. Once you have this, you can have a binary relevance and you can start to process each one of it. You can compare it, you can look at the similarity, and you can figure out for any of the queries that you're asking, it would be able to fetch you the right results. Now, what is an example of identifying the word similarity? Where do you think use these kind of similarity rules? Where to fetch it? Any application that you could think of? Web applications. A simplest application is Google search, right? You ask it some question, it is going to fetch you all the results and show you which are pertinent to a particular query that you are entering. How does it do? It is going to look at the similarity. How similar are the retrieved questions, and it gives some ranking, and then it gives all of it to you. This is possible just because it's able to vectorize the data, it's able to identify the similarity based on some score. This is what is happening.
I'm
It's
not understanding what you're saying.
are you not able to understand? Okay, I went a little higher. For example, you would want to figure out so many words are very similar to the word cat. How do you do that? You'd want to go about in pattern matching, right? For example, is this matching whatever this word is? For example, you have 01000. This represents cat. Now, is sat also equal to
सर
cat? Yes.
सर अभी से क्लास अभी कितनी देर और चलेगी मुझे कुछ वर्क करना था
Oh, abhi class hai kya? Okay. Okay. What we'll do is we'll try to wrap it off then. Okay, with this part, so that I'll also let you also go. So what I was saying is, just to complete this, whenever I want to search for cat, what I do when I have multiple of the documents, I just give it a number, and then it's easy for me to compare if these two numbers are matching. None are matching, so none of these words are related to cat. I can remove them. So this is where the word matching becomes easier. Okay, Neil, because did you have a question?
Yes.
Did you have a question for me? You raised your hand.
Yes. That I want to ask.
Okay.
So that there for like example, this is the. So
Yeah.
if I choose uh, uh, on, for example. So,
Okay.
like the has the number 10000.
Correct.
So so can on have also the same number as the?
Yeah, that's a good question. Now we want to differentiate, right? So when I give the same number, it will get confused. So we do not want that to happen. Rather, whenever the is coming, we want to just keep the unique. So we want to give the always the same kind of number, right? On, whenever I want to represent on, I'll just say 00010. Now, are the numbers standard? Probably not. You don't need to memorize, but you can start to code, making sure that each of them are represented in unique and novel ways. Okay. Having said this, Nitesh, did you have questions?
Yes, sir. Sir, my question is a little off the topic. So I
Hmm.
wanted to ask that whenever I train any AI model, it
Hmm.
never gives my any expected accuracy. It always gives very low accuracy. And so, can you tell me how can I improve this?
Okay. I mean, some basic tips is the accuracy could be because of data issue, it could be because of model issue, or it could be because of people issue, right? So figure out what is going wrong. Is it because of your data which is insufficient? Maybe you add more data, or the model that you have chosen is incorrect. You train it with better models, or the people, they might have inbuilt biases and so on. Go and fix the people issues. These are the three things that you might want to do whenever the accuracy is not coming up in the right way. Okay, we are at
Sir,
8. Hmm. Yeah, Nitish, go
sir,
ahead.
I always huge amount of data. Like I trained a model for hand gesture. Sorry, that was no, sign recognition model,
Hand
and I took
recognition.
around 1,000 image for every alphabet of the sign. And the
Hmm.
model was I trained using CNN,
Hmm.
but it was not giving me good accuracy.
Good accuracy. What is the accuracy you got there?
Uh, like about 60%.
60%.
Or
Then the data seems to be okay with you. I might still want to check how much of them are balanced data, whether you have representation from both positive and negative examples. Then I would also want to work on CNN model. Maybe the vanilla model is not working. Change the weights, change the biases, because each and every problem is unique. That's where you would want to apply different kind of model and see that what is going wrong. Perhaps it could be with optimizing it, you might get it better.
sure, sir.
Okay.
Thank you, sir.
I'll just leave it
Excuse me,
with.
can you go back to the last screen?
Yeah, yeah, sure. Where? This one?
No, the last screen before this.
This
Yeah.
one?
What
Yeah.
happens if we turn it into columns?
When you turn it into columns, you could do that. For instance, instead of having it as a row vector, I can go with a column vector, which is also perfectly okay. This is also easy for the computers to understand. As long as you're representing it in numerical form, it could be in row, it could be in column, it could be with a matrix or with a tensor. All of this will make it easier for the computers to understand it. Okay?
Okay, and so if
Hmm.
so right now we have it in rows.
Hmm.
What happens if we put the rows the other way?
The other way would mean in column or uh,
Like in rows only, like it's in rows right now. So what
hmm.
happens if we put it the other way in rows?
Other way in row. For instance, whatever is 100, you're saying it will become 001.
Yeah.
Is that?
Yeah.
Yeah, probably this will make it harder because you might have encoded another alphabet with this number. For example, you might say A is equal to this, B is equal to this, right? When you're trying to write it the other way around, take an inverse of this, maybe this might end up in also confusing the system, right? So you might want to keep it unique, but follow the same standard. If you want to represent it in column form, just maintain the column form all through.
And I wanted to ask you,
Okay?
like we have like columns and rows.
Yeah.
We if we write can we write two words in one row?
Can you write two words in one row? Possible, right? So instead of you saying A is equal to 100, you might say Neil is a genius, right? Now, you might want to represent this entire string or entire sentence in a single row. You might say this is known as embedding. So people speak about embeddings. A, what is the vector embedding that you are having? In fact, most of the ML model will not learn character by character. It will learn the entire paragraph or entire sentence or entire textbook in just one single representation, right? This is known as vector embedding. And in fact, whatever you're asking is the right question. So Neil is a genius is actually going to be embedded in some form. It might say 255 comma 0 comma 123. It might look a little bit cryptic, but it is still trying to put everything in one single row. This is known as embedding.
So like what we write,
Hmm.
computers can convert it into numbers.
Yes, that's what makes it a lot interesting. And these numbers are going to be in matrix form, right? Vectors, matrices, whatever you're learning is what it is going to be represented as.
Okay.
Okay. Okay, more questions. I'll stop the slides.
I
I
have a
just want
question. I have more questions.
yes,
Like,
yes.
how does Chat GPT get to know what we're saying, and how does he repeat it back the answer, or how
Yeah.
does he make the sentence better, like we're saying?
That's a good question. So what happens is it is converting every word to into a vector form. We spoke about vectorization or embedding, right? What it means is it converts everything to numericals and it tries to see, hey, what are all the closest in a particular vector? It starts to put them all together. This is how search results also come in. Whenever you are saying that, hey, give me something, you're asking it a question like this, it is able to pull a lot of answers. Now, what is happening behind the scenes? It is converting everything into a numerical form. It's trying to do a matching. It's pulling all the matched results and then showing it to us back. Right? That's what is happening here. Okay.
So, in
Hmm.
the voice chat,
Hmm.
how does in the voice chat,
Hmm.
like it takes some time to tell us, like
Correct.
when there's a network issue and they said connection failed, tap to retry, and we go back to the writing. How
Right.
does it show over there what he's trying to say?
So what happens with voice is someone is speaking. Let's say someone is speaking something, right? And then what happens is it is converting speech into text. So you are speaking, speech is converted to text is converted to a number,
Something
and
like
then
text to speech.
text to speech, speech to text. This is exactly what goes on behind the scenes.
Yes.
Okay. The latency is just because, why is it slow? Because it's doing a lot of operations behind the scenes. Now, each of them will take a lot of time. That's where you see it to be slow as well. Okay.
So,
Hmm.
like, there are only some people working in chat gpt, like there might be many people. So what
Yeah.
if one person
Hmm.
in chat gpt has to attend with two people at one time? What will happen? How will he do that?
So you're asking, two people are asking the same question to Chat GPT. What's
No,
happening behind?
no,
Yeah.
two people are asking different questions to one person working in chat gpt. How is he
Oh,
going to
yeah,
tell
yeah.
about both of the questions to
Now
get them?
that where computers come in handy. There is no person involved, right? So Chat GPT removes the person there, and then it installs computers. So computers can cater to multiple people at the same time. So
So
that is where
like
it
he can,
is.
so he, this is what can happen. Like he can speak for one person and he can type for one person.
Very good. That is known as multiprocessing. So we all do multitasking, right? For example, we are on the screen, we are also scrolling our phone, we are also listening to what our parents are saying. We are doing multitasking. So very similar kind of multitasking is what computers are able to do. So the more number of processors that you have, people speak about, hey, this is a quadra processor, this is 100 processors, and so on. It could do so many different tasks at the same time. Okay, that's a very simplistic view. I'm
So
oversimplifying.
so only
Yeah,
the numbers of, so the only the number of processors can answer the answers that he's giving.
correct. The more the number of processors, it can handle so many requests at the same time, right? So what we as computer scientists do is we try to make sure that the computers are able to multitask. It's able to do multiple things at the same time. All right. There are STEAM Varsity team. I just wanted to check. Do I have more time, or how do I have more time by. I'm okay to
Yes, sir.
continue.
Please feel free. Yes.
Yeah. Okay. Okay.
Um, so I have a question.
Yes.
We are building a humanoid robot here, but there's one problem. We have trained a model and we have also uploaded it into Raspberry Pi. But
Okay.
there are it has so much delay. When we speak, it took around 10 or 20 seconds to respond. Like
Yeah. So it could be just because of the limitation of Raspberry Pi as well, because it is underpowered. When you relate it to a computer, which has a lot of RAM, it has a lot of processing speed. Raspberry Pi is relatively a smaller model, right? The hardware, what you are having at this point of time is limited. So one thing that you might want to do is optimize the ML model also to only suit whatever goes into a Raspberry Pi, because it's learning a lot of things. You don't need heavier models. Try to reduce your model size or use a better hardware. So in your case, what I would recommend is still keep Raspberry Pi, but try to go with smaller models which will fit in into the memory, because memory is taking a hit. It's probably losing out there.
we can only use effective questions in model training to train it.
Correct. You
For
can
this
reduce.
size.
You don't need to. For instance, it's like learning 8 subjects at the same time, right? So rather, you might say learn only 2 subjects, but learn it well. Now that's what you are doing. Your models also to do. You're not asking it to do multiple of the tasks. You're trying to reduce it. This is known as distillation, right? You use some distilled model. Distilled model will help you in reducing the overall model size. Okay, Sumit.
Okay, sir.
Okay.
Thank you.
I don't know who else is in the queue. Noel, Noel, do you want to go? Me?
Sir, I had a question that was sort of related more to the career side.
Sure.
Yes, sir. So I just wanted to know, if you could briefly tell how you decided to pursue like AI research? Was it something you sort of so you
Yeah.
like discovered and then you liked it very much so you wanted to pursue a PhD in it, or was it something you grew to like later on?
Yeah. I mean, that's a good question, Noel. In fact, you kind of answered what the journey was. I graduated in 2006 with my engineering. I started as a full stack developer. Started working on multiple of these things. Over a period of time, I got a lot more projects. I got the opportunity to work on computer vision, recommendation system. In Amazon, I was primarily building recommender system and so on. At that point, when I was seeing through, I figured out, hey, this side of the world looks even more interesting. Maybe I'll go a little deeper. And then I figured out maybe I need to do PhD alongside. That will also keep my foundation stronger. So I tried to balance it out. I did my PhD alongside work. It took me a while, but it was worth it. So after that, I started leading more teams, becoming a full-fledged ML scientist. But this was a transition that happened eventually. Now, for you all as well, it could be something that you might like, you might not like. There are people who switched into full stack roles because that is what their passion was. Go into anything. My suggestion is don't stick onto it. Whatever your calling is, try to figure this out. How you do it is fail fast, experiment, fail fast. Certain things work, certain things don't work. For example, I was a full stack developer. I told you I was also mobile developer. At some point, I figured out it was what was interesting at that point of time. Later, it was data. Later, data science. So keep switching. You understand what really suits you. Maybe a few years down the line, I might be in a totally different path as well. Technology is also evolving very quick.
Sir, I had a follow-up question also to that.
Please,
So
please.
if I had to relate it to my experience right now, actually what happened is, so I just completed college recently.
Mm.
Uh, so I did it in the life science background, BTech in biotechnology. But lately I have sort of wanted to switch to a different line, sort of more into robotics and that sort of thing. So, you know, family wise, there's also the discussion like try to take that something that's more related to your background,
Yeah.
more life science based. I wanted to know your advice on it. Like, I feel like I would like this line more than my
Yeah.
existing line, but I'm not sure because I've not tried enough, and I don't know if I'm supposed to take more time before getting into it.
Yeah. Good question, Noel. Uh, in terms of what you want to do, you take it up. For example, my own background in undergrad was mechanical engineering. Later, I switched to computer science during my postgrad. Right. So don't worry about how the conventional career style has been. Things have changed a lot. And right now with me, whoever is working, they come with various of the background. For example, there was this recent Nobel Prize awardee, which one of the Googler got. And what their work was on understanding protein structure. And they were working on AlphaFold, which is our way in which we use AI for leveraging. And they come with a good background of both biology as well as computer science. Now the world is going towards something where you have to understand multiple domains, and you're also going about and frequently updating, upgrading yourself. So at this point of time, go with what you believe is the right thing to do, right? Whatever I and others could say is primarily going to not be from your context. It's very contextual. So at this point of time, if you feel your true passion is this, switch. But how do you identify whether it's you're truly passionate about? Take up some hobby projects and try with those hobby projects. Are you really immersing yourself? Are you able to figure out some way of contributing back to the society? Because at the end of the day, you also have to make money, right? You can't uh, uh, you can't do it for charity. So figure out if this is something that the society needs. Is this something that I like? Is this something that I'm passionate about? And be it in your own field, you could go deeper. There is an option. I told you about AlphaFold. Similarly, there are multiple of these uh, uh, life sciences plus biotechnologists who leverage latest of this AI and they try to cross contaminate each one of them. So try to own such fields as well. Perhaps start doing your post graduation, start doing your specialization with PhDs and so on. All of this are pivotal, but don't do it for the sake of degree. You'll probably end up in again realizing, hey, this is not what I wanted. Right? So take some time. It's perfectly okay to take a break, to take do some hands-on work, join some company, do some internship, figure out if that's what really suits you, and then over a period of time, you yourself will realize it. Retrospect, realize what's right, what's wrong.
Just one last question.
Yes,
Uh,
please.
so you
Sir,
mentioned something very important. So you also switch backgrounds, right? From BTech in mechanical engineer to a computer science background.
Correct.
So I am probably in the same boat. And so any tips you would have for somebody who's doing that? So one thing I've already said, if I take a master's in some other program, will I forget will I struggle to learn the foundations that a
Yeah.
BTech in computer science will learn probably. Was there
Uh,
any
we had a very similar kind of question, but when you notice it, probably first year is common for everyone. Fourth year goes in internship. Whatever is remaining is second and third year, right? So about 2 years is not going to be very hard to pick up with whatever you're going to do in the subsequent years. And I realized over a period of time, now I'm almost completing 18, 19 years. It makes it, at some point, I realized, hey, I could just stay where I am and keep regretting, or I can just pick up. Now there are a lot of courses available. MIT X Open, almost everything that they teach at MIT is available at your hands, right? In your mobile or in laptop. Similarly, there is NPTEL, which gives you all IIT lectures right at your desk. So leverage these things. It makes it you don't even need to pay for these, right? Most of them are free for you. So these get started, and you can you'd realize that the switch will take you some time, but it's not very hard. It's easy to bridge the gap. I mean, over a period, that's what I did as well.
Thank you, sir.
Okay, who's
excuse me,
next?
sir.
Okay, yeah, Vikas, do you want to go next? Go ahead.
Actually, I am Vyom. I have joined from my dad name. So
Got it.
I have a question like a kid is using Gemini.
Okay.
Like if I am using Gemini
Hmm.
and there is a app like Gemini Kids.
Hmm.
So if I ask like a question in Gemini like what is the lifespan of human? So
Hmm.
first it will answer the question, but then can it uh, send a message to us and like say that you can use Gemini Kids.
Yeah, I don't know, Vyom, if there is Gemini Kid. Is there an app like Gemini Kid, or you're just suggesting this as an idea?
I'm asking it to you.
You're asking it. Actually, that's a good startup idea. Why don't you start up something like that? And you restrict it to only whatever the kid content is. In fact, I being at Gemini, I contribute to Gemini, but I have never thought about something that uh, we can kind of fork off only for kids. But that's actually a very good idea, you. Now, whatever you were asking, would it be able to interact, send a message, and so on? These are some good things that we could do. But even now, with whatever environment you have, for instance, you have this Gemini, right? You say, I mean, treat me like a 5 year old or treat me like a 8 year old. The responses vary according to whatever level you are setting in, and then you can still interact with it. At the same time, whatever it gives you, you can go about and fine tuning or prompt tuning. This is called prompt engineering. So you try with various prompts and you try to figure out what is the right prompt to answer you. Does it make sense, Bio?
Yes.
You should also consider starting up on your own at some point. Okay, you should not work for someone. Rather, you should start up your own company. Fine. All right. Okay. Who's next? Paras, you're next.
Yes, sir. So I had a question related to natural language processing, and also the thing that Vyom said,
Yeah.
Gemini kids. So
Yeah.
I just wanted to I had this question that when fine tuning the large language models,
Mm.
you must have a number of questions, a lot of data. So
Mm.
to be specific, I was working on Gemini
Mm.
and fine tuning it for a particular task, like just
Mm.
creating a chatbot.
Mm.
So it will answer the questions related to a particular domain.
Mm.
So I was struggling to make it very specific to that domain. So if you can suggest some tips and
Yeah.
something that how to
So
fine tune it.
Uh, one way is you can take the base model of whatever. For instance, Gemini is not a base model; it's a very large model, which means it's trained on billions of parameters, right? Now, what could these billions be looking like? It might be trained on science data, math data. It could be trained on sociology data, and so on, political science, and so on. But for your problem, you might be just focused on only math related. You might not be interested in this. So one way is you can start to distill it, as I told earlier. So distilling a model will make it reduce from billions to millions, right? Millions of parameters, or it could be thousands of parameters as well, depending on how small you want to make the model. That's one way. Second way is you take the vanilla model, which is going to be on the base variant. You try to fine tune and up level it. So you add more of your domain data, and with this domain data, you try to up level. This is fine tuning. Either by distillation or by fine tuning, you can make it better. Since you are now using Gemini, what I would say is third approach is by using something known as RAG. You probably might have used retrieval augmented generation, where you're showcasing it and you're saying that, hey, you have a lot of data with you, but first thing that you are going to refer is my own domain document, right? So first look at answers here. If it's not giving you the results, then go for others. Now this way, it becomes a lot more easier for you to answer from your specific data.
Like
This
creating a kind of a knowledge base.
knowledge base, and then you are saying that this is my always my first stop. You first need to refer here. If you don't find an answer,
That's my
then go
first
to
priority.
correct, correct. That's what. And the technique that you use there is RAG, RAG, retrieval augmented generation.
Okay.
Okay, who else? Devesh, you are next.
Yeah, so hello sir. So
Yeah.
I have been actually been working with games, but for some time I'm trying to create NPC models using AI and ML. But
Mm,
what I have recently, like how should I say, I like hit a wall, and
mm,
although the NPC models tend to work good, but they
mm,
end up crashing my system a lot. And if they do work great and my system is also going on, there's a
mm, mm,
problem that the behavior is a bit too laggy. How should I say? If I wanted to
mm,
answer or behave it in a certain way, it
mm,
does not end up very well for a game. So sometimes I
mm.
wonder, is it really smart to combine games and AI?
I worked in Disney on games on gaming platform. Gaming is harder, especially when it comes to you forming various of these. You take in a lot of heavier objects, right, on the screen. Whatever assets you're forming is all going to be high resolution. One way is to reduce the resolution over there. Second thing that you could, I mean, on whatever the browser elements are, whatever you are showing on the screen. Second, with respect to AI, because it also involves multiple of these components, it makes it harder for it to interpret multiple things at the same time. So use state of the art either on whatever the game board models you're planning to use. It could be for object recognition, it could be for gameplay, it could be for identifying various levels and so on. You might improve on the selection of models. That's one way of improving it. What techniques are you using here right now, Devish, for
Uh,
building it?
Yeah, I will be frank about it. Basically, the idea that I am working with a friend of mine is the whole matrix theory that that sometimes people go on about. We are trying to create a world where we can train our AI models to behave like an actual human, and since games we can control the whole timeline, we
Yeah.
aim to just create a civilization even
Hmm.
quite close to a basic human behavior. But
Yeah.
as the AI sometimes tends to go on, it breaks, or it actually ends up breaking my system.
I know, I know. MMOGs, like massive multiplayer online games or any kind of games which requires you to plan out the entire of this, simulate it, is a harder problem. Try to break it down, see where is it failing. Ideal portion here is to do some kind of profiling so that you understand what exactly is the bottleneck at this point of time. It could be with respect to the inference from the model, or it could be the data it's consuming. So break it down. Once you have the breakdown, it makes it easier for you to go and fix that particular issue.
So I should just focus on providing it less data for now instead of just
Data,
bombarding it.
correct. And also try to granularize it. Do something known as profiling, network
Okay.
profiling. So this helps you in understanding what are your current bottlenecks.
Okay, sir. Thank you,
Okay,
sir.
Sumit is next.
Sir, I wanted to ask, like, in any chatbot like ChatGPT or Gemini, it blocks the inappropriate things like when we ask. So how that ChatGPT or any chatbot do that? And also, like, there are some people who generated a prompt which can be used to get inappropriate content from ChatGPT and Gemini. Like, you can
Correct.
say they hacked or something
Yeah, yeah,
using
yeah.
prompts. Yeah. So I
That's a
just wanted
serious
to ask
issue.
that.
So what these models do behind the scene is, so you have Chat GPT or Gemini or any LLM. So
Yeah.
what it does is it adds a filter, right? So it adds a filter before and after. That's what goes behind the scene, right? What this filters does is it tries to look for some keywords. For instance, someone is speaking about some banned word. For example, someone is asking about death, right? So this is not something that we should be
Asking.
answering, or we should be requesting as well. So probably you might want to add this into block list, right? What this block list will do is whenever you ask something about this, it will say a generic answer. Hey, sorry, I'll not be able to give out an answer. It acts like a filter. So what each of these, like Gemini or Chat GPT or Llama, will do is add these filters before and after. But despite this, there are instances where it has given out the answers which it
Yeah.
should not do. That is where we are making it intuitive. We are trying to make sure that it is also not giving out such answers. So this block list needs to be expanded further. So we keep expanding based on the responses that it gives at every interview.
Mm.
Makes it easy. Okay. Okay, Vyom, you're next.
Sir, I wanted to ask that if I have Gemini and Chat GPT in my phone, so if I ask something from Gemini, so can that also if I ask something from Gemini, uh, and I also have Chat GPT, so if I ask something from Gemini, so can uh, Chat GPT also recommend that to me?
No, it might not. The reason is it's like basically there is a separation, right? Gemini is owned by Google, and then ChatGPT is owned by OpenAI. So these companies, they do not want to interact with each other. Had Were they interacting with each other, then you would have the recommendation coming. For instance, you ask something here, it will come up here. But because there is like a wall where they are not interacting with each other, now you know that this is not speaking to this. So whatever you are asking, it will remain only within that environment.
So if I say that I download Gemma and Gemini then?
Gemma and Gemini, it might, because it's all within Google, right? So Gemma is here, Gemini is here. So that is where it might interact. For instance, if you ask something on search, it will show up on your YouTube as well, because search is also owned by Google, YouTube is also owned by Google, Maps is also owned by Google, right? So whatever you are doing here, you might see recommendation coming up in YouTube or Maps. But other than this, it's like a very big wall which is residing between companies. Okay, all right. Noel?
So just one question about Gemini and ChatGPT. So,
Yeah.
so for example, the data, it trains itself based on the data that you have provided on the backend, right?
Hmm.
Does it also train itself based on our responses? So, for example, I for based on our prompts and the response that it generates, does that also somehow
Uh,
impact?
I mean, in fact, that is where some of the problems came in. The data that it is taking in. Right now, most of the companies, they don't go with training it on the
User.
user, right? Because the user data might be manipulative. There are a lot of chatbots which started learning the user prompts and responses, and it ended up in giving out inadvertent results, which it should not be, because there are a lot of malicious players who try to bombard with a lot of inadvertent data. Now that is where what right now all the companies, all the major companies, be it Amazon, be it Facebook or OpenAI, what they do is they have only trusted sources of data that it trains on. So whatever the user is giving, probably not at this point of time, because everyone had had one or the other roadblock by learning from some of the malicious users. So they do not want to end up in doing that mistake.
So it's kind of safe to say that it's like the data that we provide that in our prompts and stuff, and whatever is being generated, it's not being stored at the back end of ChatGPT or
It's
Gemini.
probably not going to be stored. Maybe it might be stored for analytics or trying to figure out, hey, this results were incorrect and so on. But it might not be used for training the model. Yes.
Thank you.
Okay. 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 Any other questions? Yeah,
Yes,
Nitesh.
sir. I have a question related to data. Well,
Okay.
it may sound unrelated, but if you got the data about the people, the data
Okay.
that is their behavioral data or their daily data, kind of their activities or anything, how will you use that data? Like as we know that there are multiple ways you can use data. Like personally, how would you opt to use that data? Not
So,
like how Google use it, but just like you personally.
so when I'm looking at it, it depends on what is the outcome that I want from it, right? Whether I want to build a product, or it's about getting some insights, or making sure that I am able to visualize in some form or so on. Now, what most of the companies do is they try to see that, can I build a product which is commercially viable? Can I also make it useful for someone? Right now, when YouTube is recommending you some video, it is not just on the basis of making money, but it is also making sure that it is satisfying your curiosity, your need, what is needed at that point of time. So, what I would do is figure out where exactly am I going to use this? Is this ethical? Ethical consideration also plays a role, and then would I be able to see something out of it? If it's my own personal data, I might want to use it for improvising myself. If it is someone else's data, I might want to see that, can I build a product? Can I platformize it? Can I make it better? Okay, it is purely contextual. Yes.
Okay, sir. Thank you.
Okay, Nitish. Perhaps last question. I know it's too late for others too, and 8:37. Maybe one last question, Nitish.
Yeah. Yes, sir. I have a question from a recent news. I heard that the AI models are replicating themselves when they are believed to that they are going to be shut down. So, what are your views on it? Like, what dangers it could bring up? And
Hmm. We are speaking about artificial general intelligence (AGI), as they call it as, right? So
Yeah,
how far are we? Are we close? Perhaps the rapid pace of everything that's happening, yeah, it is pushing all the timelines sooner than what it is. But would we probably let it take over everything? Perhaps not. That is where regulatory and governments might come in, saying that what is ethical, what is not ethical at this point of time. Right now, a good number of models are also stopping it from doing things which it should not. So that is one way of looking at it. But is this bound to happen at some or the other point? It's bound to happen. There are a good number of transformations also that is possible. For instance, a number of new jobs might be created on the positive side. On the negative side, it might remove a lot of jobs as well. So we need to stay on top of it. At this point of time, we have to embrace whatever is coming. For the generations to come, I think it's all pivotal moment. AI is a pivotal journey. What has happened in our lifetime at this point? Am I like a AI robot? Probably. I don't know. If it's should I take it as a compliment or otherwise? Okay. All right. It was very nice talking to you all.
Sir,
Yeah, yeah.
sir, I have a very last question. It's like little bit childish, but still, do you believe that the AI
Yes.
will take over the world?
AI, I mean, that is what I was telling. AI might, it is building all the capabilities. Now, almost all of us are becoming very lazy as well, right? We don't even do the basic research. We just go to ChatGPT or Gemini and ask the questions. I think if we are doing that, perhaps yes. But again, embrace whatever is coming up. It's happening. Probably use it in the right sense. Will it take over the world? Is a question. Maybe we might put in restrictions from it to not happen, but the future is unknown even to me. I'm just going with the flow, whatever happens. But all of these are exciting times. So take it in the positive spirit. All of this, our previous generation didn't even see it, right? But we are getting to see, we are getting to work on it. Just go with the flow here. Okay, I hope this was useful in some or the other way. I hope you got some of the other points. Just to conclude, going back, relating to math, it is important that you still play a role in understanding and developing your fundamentals well, which is going to be useful in AI. Look at all possible tools, and one of the tool that really helped me is all of these LLMs. But other than this, there is also this book called Deep Learning, which is something that I would recommend you. Especially, there is this part 1 of the book, right? Is all available for free, right? I would highly recommend that you take over it. Just look at whatever we spoke of, whatever operations that we were talking about is all here. Please do so. Okay, all right. Okay,
Yes,
cool.
sir. So I
Any
just wanted to say one thing, that we really are always bonded by the time, and so I would really want and love that if we can get like sometime some other time, if we can get this time to communicate with you, or we can connect
sure.
with you. So
Definitely, definitely. I mean, STEAM Varsity team has been following up with me, so we will stay close. We'll also see as much as possible. I'll try to uh, again come online some of the days. Okay.
thank you, sir. Thank
Uh,
you.
Thanks.
On
Thank
LinkedIn
you
and
so much, sir, for the time and effort you put for all of us. And as you can see, the logo of STEAM Varsity is itself a hand which promotes asking questions, and we use that as a medium to reach new heights. And while we were thinking of a name for this, we thought of choosing different things, maybe like Steam Talk, but at the end, we finalized Steam Chat because of how informal it is and it promotes people asking questions, and that is what our motive is. And again, sir, thank you so much for sharing your knowledge with us. I think all of us had a great time and got so much knowledge for you. Thank you so much for that.
awesome. Thanks so much for the opportunity. It's a pleasure talking to everyone. The spectrum of people who attended this is quite wide. So I see someone in in probably about 10-year-old to about 25-year-old. That's the spectrum of age group. So I really enjoyed. I hope it was something that was mutually beneficial as well. I loved.
Yeah, sir. We have people from all age group, and I'll also like to invite Monica, ma'am. Yes.
Yes, sure, Adya. Mithun sir, thank you so much. Firstly, we would like to appreciate your efforts that you took out time from your busy schedule, even on a weekend. It's so kind of you. I hope you remember that we first met at Google AI Academy event held in IIT Delhi.
Yeah,
Your
yeah,
session there means there was on the topic of responsible AI. We got to know about responsible AI first time. It was so incredibly insightful. Yeah, because means the from that session we got to know the AI also can be so biased, and to mitigate that biasness, this responsible AI factor is means matters a lot. And now today's session was also equally engaging, and I saw that students have asked so many interesting questions. Means they are repeatedly asking. We are running out of time, but still they were asking. It was so incredible. And yeah, the topic means today's topic mathematics itself, it's very complex, and the AI, it's a bit more difficult to understand, but the way you told about each and every aspect, it was so grateful, sir. I'm so confident that students have gained so much insight from this session, and we seek your mentorship in future as well. I hope to
absolutely.
see you whenever you visit in the Delhi NCR. Please visit to our makerspace.
I will. Yeah, I will. And well, it's really a pleasure. I got to learn about a lot of new things while I do this, and the bunch of kids that you have is amazing, right? There were a lot of interesting questions. I'll also take it back, especially the ideas that came in Gemini kids and so on. It's all interesting.